Okay, welcome back again, guys. Session 8. Hopefully it's gone okay up to now. This is the last session of the day, so just last big effort. We're carrying on with quadratics, but what we're going to look at today is what I call secret quadratics. So quadratics that may not look like a quadratic, but we can manipulate them so that they are. This is a big topic at A level, okay? Big topic at A level. These sort of questions come up a lot. So do take some time to really understand this session, and also make sure you copy down the notes nice and slowly and really try and understand what's going on. Okay? Right, okay, I'm going to disappear again, guys, but good luck with this session, and any issues, obviously, let us know. Okay, secret quadratics. Now I'm going to go straight in with some examples on this. So if we go e.g. 1, x to the 4 minus 3x squared minus 4 equals 0. Now, okay, so you're solving this. Now, at first glance, this looks like a quartic, doesn't it? We've got a power of 4 there. It's not a squared. But we can make this a squared by doing a clever substitution. So I'm going to think, what can I substitute here that will make this into a quadratic? So I'm going to substitute. I'm going to call u equal x squared. Okay. Now the reason for that is if I let u equal x squared, well, the first term here, x to the power of 4, well, that's going to be u squared, isn't it? Let's just do a side working here. So because if u equals x squared, u squared will equal x squared squared, which is x to the 4, which is what I want. Now the next term, well, x squared is equal to u, so that's going to just be 3u. And the final term, well, that doesn't change, minus 4. I've now changed this into a quadratic, which I can now, using all the tools from before, this one will probably factorise, yeah, I think it does. We're going to get a minus 4 plus 1. That does work. Times is to minus 4, adds to minus 3. So my u is going to either be minus 1 or 4. Right, I don't stop there because my actual answer was x, wasn't it? Not u. So then x squared must equal minus 1, or x squared equals 4. Now this, we can't square root a negative, so there's no real solutions for that particular answer. But over this side I can do that. If I square root both sides, x is going to equal 2 or negative 2. And that will be my answer. Right, and I can always with these go back and check in the calculator. If I go menu, equation mode again, polynomial. This is a degree 4. So it was 1x to the power of 4, no x cubes, minus 3x squareds, no x's. Oh, hang on, I need to go back. So it was 1x squared minus 3, no x cubed, minus 3x squareds, no x. If I make that negative 4. 2, negative 2. Now that is a complex number. That's coming from this solution, but that doesn't, for real solutions, that's not a real solution. And minus I, again, that comes from over here. So any with I in, you don't need to worry about just yet. So we know that's correct, okay? So that's the first one. Let's look at another slightly harder one. So let's go for solve x minus 10 root x equals negative 24. Okay. Now again, a temptation here is for everybody to square each term. So do not square each term. That's a bit of a disaster if you do that. So do not square each term. But what again I'm looking for here is a clever substitution that's going to make this into a quadratic. And you might want to pause and have a think about what you could, so what could I let u equal that would make this a quadratic? And what would work, you'll find, is if I let this equal to root x. because if u equals root x, again, if you're doing any side working, just put a bit of a title side working there. U squared is going to equal x if you square both sides, which is really nice because x now is u squared minus 10u equals negative 24. Okay, I can add 24 to both sides. Okay, equals 0. This one will probably factorize again. Most of these will factorize, to be honest, guys. And this one does factorize quite nicely. We've got a minus 6. That times to 24 adds to minus 10. We've got a minus 6 and a minus 4 there. So u is going to equal 6, or u is going to equal 4. Now we don't stop there. Remember, u was root x. So root x equals 6, or root x equals 4. And to get rid of the root, I need to square both sides. And if I square both sides, I get x is equal to 36, or x is equal to 16. Okay, and there we go. That's our answer. I can check all of the ways to check these answers by plugging it in back up to the original there. Okay, so I know I'm right. Again, if I'm going to do a quick check on my calculator, I'm just going to go back to the normal way. So mode 1 takes me back there. If I put in, so it was x. So if I go x minus 10 root x, so that was the left-hand side of my equation. If I press calc and input 36, I get minus 24, which was the right-hand side, so I know that's correct. And if I press calc and check the other one, 16, I get minus 24, which again is correct. So again, please use the calculator as a check. Those are the hidden quadratics, secret quadratics, or hidden or disguised. There's lots of different terms for this. The worksheet I said again, it's I want you to do all the questions, please. It starts off a bit easy. It tells you what you need to substitute in for u, and then it gets a little bit harder later on when you have to decide yourself what you need to substitute in for u. Okay, the answers are there as well, so do check your work. That's the last session for today, guys. Well done, and tune in for session 9 next time. Thanks a lot.